In this video, we want to look at the nth root of a complex number, how to calculate it using Euler denotation. So there are some identities that we already know, which is minus 1. Minus 1 is already exponential I pi plus 2k pi. Then for 1 is equal to ei 2 pi plus 2k pi. And I is ei pi over 2 plus 2k pi. The reason is because we already know that I square is equal to minus 1. I square is already equal to minus 1. So these are the things that we know. It means any number given to us, we are just going to convert it using these identities that we have. For example, if we're asked to find all the values for z, let's say z raised to power 4 equal to minus 1, for example. For us to do this, we know that it will be equal to z equal to 4th root of minus 1. Now, according to laws of indices, we can say z is equal to minus 1 raised to the power 1 over 4, according to laws of indices. We already have an identity for minus 1, which is equal to, we say that z is equal to, for minus 1, we know that it is e raised to power I pi plus 2k pi. Now, this k is a constant. This side is a constant that we added to all of them. K ranges from the power, if we say n is the power. So, k is always equal to from 0, 1 until you get to n minus 1. In this case, we have 4 to be n, so 4. So it means that the value for k is going to range 0, 1, 2, 3, because 4 minus 1 is equal to 3. So we have 0, 1, 2, and 3. If peradventure we have something like 5, the value for k will be 5 minus 1, 4. So we'll have 0, 1, 2, 3, and 4. If we have 3 up there as the power, we're going to have 3 minus 1, 2. So k value will be 0, 1, and 2. So let us proceed. So in this case, we're going to find the value of z when k is 0, the value of z when k is 1, and 2, and 3. So we stop at m minus 1. So 4.4 minus 1 is 3. So for when k equals 0, we're going to have ei pi plus 2. Instead of k, we replace it with 0 and then raised to power 1 over 4. So here, 2 times 0 is 0. 0 times pi is pi. So on this whole side, 0. Now left here and here. Pi times 1 is pi divided by 4. So the answer is going to be ei pi divided by 4. This is the first answer when k is 0. When k is 1, we're going to have ei pi plus 2 into 1 pi raised to power 1 over 4. 2 times 1 is 2. 2 times pi is pi, 2 pi. So 2 pi plus 1 pi will give you 3 pi. So 3 pi times 1 will give you 3 pi. So 3 pi over 4. What we'll have is ei 3 pi over 4. We don't touch the I because I is what shows that it is a complex number. So we have also when k is 2, we're going to have ei pi plus 2 into 2 pi raised to power 1 over 4. So we're going to have 2 times 2 is 4. 4 times pi is 4 pi. So 4 pi plus 1 pi will give you 5. So that's 5 pi. So 5 pi times 1 is 5. So 5 over 4. So we have ei 5 pi over 4. Now remaining one when k is 3, we're going to have ei pi plus 2 into 3 pi raised to power 1 over 4. We have 2 times 3 is 6. 6 times pi is 6 pi. So 6 pi plus 1 pi is 7 pi. 7 pi times 1 is 7 over 4. So we have ei 7 pi over 4. So all the roots therefore are ei, that's from here, ei pi over 4, comma, ei I 3 pi over 4, comma, ei 5 pi over 4, comma, ei 7 pi over 4. These are the possible roots. Another question is z3 equals minus 8. Now, if you check in our identity, we don't have anything like minus 8. But we're going to rearrange this question to look like what we have without necessarily changing the question. The reason is because we can say that z3 is equal to, we can say 8 times minus 1. It will still give us minus 8. We don't have an identity for 8 or minus 8, but we have an identity for minus 1. So we create it in a way that we will have an identity. So because of that, we can say that z3 is equal to 8 then minus 1. Therefore, we have that z alone is the cube root, which is 8 raised to power 1 over 3 times minus 1 raised to power 1 over 3. Now that we've created it this way, we can make them look like, for example, this way. We can say that instead of writing this 8, we can make it look like this power by applying laws of indices, because 8 is the same thing as 2 raised to power 3. Because 2 times 2 is 4, 4 times 2 is 8, so 2 times 2 times 2 is 8 raised to power 3, then raised to power 1 over 2. Also times minus 1 into 1 over 3. So if we have gotten it here, it means 3 times 1 is 3. 3 divided by 3 is 1. So what we're going to have on this side is just 2 times minus 1. Instead of writing minus 1, because this is 8, we can replace the minus 1 with its identity. The identity of minus 1 is ei pi plus 2k pi. Then we still bring the power 1 over 3. Now that we've done this, remember k is going to start from 0 to n minus 1. The power that we have is 3, so n is 3. So we're going to have k when it is 0, when it is 1, and when it is 2. Because 3 minus 1 is 2. So we have when k is 0, we're going to be having 2 ei pi plus 2 into 0 pi raised to power 1 over 3. So if we multiply out 2 times 0, everything here is now 0. So what is left is pi here. Pi times 1 is pi over 3. So what we're going to have is 2 exponential I pi over 3 as the first answer. When k is 1, we're going to have 2 into ei pi plus 2 into 1 pi raised to power 1 over 3. 2 times 1 is 2. 2 times pi is pi. So 2 pi plus 1 pi is 3 pi. So 3 pi times 1 is going to give you 3 pi over 3. So 3 pi over 3, let me write it out, is going to look like this. 2ei pi, okay, 3 pi, I beg your pardon, 3 pi over 3. And you know this 3 can remove this 3, so that we will have 2ei pi alone. So when k is 2, we'll have 2 into e pi plus 2 into 2 pi raised to power 1 over 3. We're going to have 2 times 2 is 4, 4 times pi, 4 pi, 4 pi plus this, 5 pi. 5 pi times 1 is going to give us 5 pi. So 5 pi over 3. So 5 pi over 3. So these are our answers, 1, 2, and 3. So we pick this one, 1 and 2 and 3. So these are 3 possible answers. We write them out. Another question is z squared equals 16. Here, remember our k is n minus 1. So 2 minus 1 is 1. So for here, k is just going to have 2 values. 0, and 1. So we can reduce this and say z is equal to 16 times 1, because we don't know what 16 is, but we know the value for 1. So we can put it as 16 times 1 to create what we have, so that we have that z is equal to 16 raised to power 1 over 2 times 1 raised to power 1 over 2. Now we know that 16 is the same thing as 4 squared 1 over 2 to make it look like what we have outside. And also 1, we have 1 over 2 here. These two can cancel these two. So we have that z is equal to 4. Instead of writing 1, we can replace it with its exponential form, which is ei 2 pi plus 2k pi, then 1 over 2. So now that we've gotten here, when k is 0, it is giving us 4 ei 2 pi plus 20 pi raised to power 1 over 2. So here we have 4 first of all, e and I. 2 times 0, all of this place is 0. 2 pi is left. 2 pi times 1 is 2 pi. 2 pi over 2. So 2 can cancel out the 2. We have only pi left. So ei pi. So this is the first answer. When k is 1, we have 4 ei. So for here, we have e. Okay, let's write it out first. 2 pi plus 2 1 pi 1 over 2. So we have 2 times 1 is 2. 2 times pi, 2 pi. 2 pi plus 2 pi is 4 pi. 4 pi times 1 will give you 4 pi. 4 pi over 2. So let's write it out. ei 4 pi over 2. And you know that 2 can go. So that what we'll have is 4 ei 2 pi. So these are the two answers, the roots, ei pi, comma, 4ei 2 pi. These are the roots. Please subscribe to my channel and share the video.